Okay, guys, let's take a look at the warm-ups. We've got the first one here. How did you guys solve this one? What did you do? Put it in log form. So we know if we have a to the b equals c to start with, that we can rewrite that as log base a of c equals b. And that's a really good way to do a problem as long as it's written in this simple exponential form to start. So for this problem, we can literally just do log base 5 of 11 equals x plus 3. And then to get x by itself, we would have to subtract 3. So the answer should be log base 5 of 11 minus 3. You cannot subtract the 11 and the 3 because this is all together as 1. Any questions? Anybody get that same answer? Great. I also want you to remember our change of base formula. Do you remember how we can change this into any base we want? So another way this answer could be written would be log, and if I use base 10, I could just do log 11 over log 5 minus 3. Okay? So if somebody gave me this answer on a test, I'd have to accept it. It's the same thing, right? Remember by change of base formula. Okay, I want to show you how to do this problem another way now. When we have an inequality, meaning less than or greater than, this method will not work. The inequality doesn't go the right way. So to save you that aggravation, the other way we can do this is to use inverse operations. What's the inverse operation of an exponential? A log. So I could do log of this base. So log base 5 of 5 to the x plus 3. And I'm going to do the same thing to this side. Whatever we do to one side, we have to do to the other. What happens if we have an exponent and we have a log? What can it become? Coefficient, right? And what is log base 5 of 5 equal to? 1. Do you see how I'm going to get that same answer doing it this way? I'm now going to subtract the 3, and I get the same exact answer doing this with the inverse operation. And this is the way you're going to want to do it when you have an inequality. This is going to be the best method. Inequality meaning less than or greater than. The other way we can do this is if I have that same problem doing it one other way, is I can take the log base of anything. What's the most common log base we use? 10. So I can do log base 10 of 5 to the x plus 3 equals log. Whatever I do to one side, I do to the other. I just took log base 10 of both sides. What does the exponent become? Coefficient. Now, this would have to go in parentheses, that x plus 3, because that whole thing becomes the coefficient. And now when I distribute, I get x log 5 plus 3 log 5 equals log 11. And so now I could write this as x log 5 equals log 11 minus 3 log 5. And then we can just divide by log 5 on both sides. And we could get that answer right there. That would also actually be equivalent. If I type that into my calculator, that should be equivalent. Any questions on that? It doesn't seem correct, but it should be. So that decimal approximation must be equivalent to whatever these end up being too. All right, back up here. What's the answer to this going to simplify just to be? 3x plus 5. If we have an exponent, it becomes a coefficient. What's log base 4 of 4? 1. So this is just 3x plus 5. Okay, what about this one? If we have 7 raised to the log base 7 of 2x plus 3, what's that just going to be? 2x plus 3 because those are inverses. All right, go ahead and bring up your notes for section 6.6, part 2. Oh, I was like, that's a thing, but I have to last time we just evaluated it, the third step. Go ahead. Okay, section 6.6, part 2. All right, so as you're getting that pulled up, just going to read through this. How to solve exponential and logarithmic inequalities. We've done equations, but we haven't done inequalities with less than and greater than. If you have an exponential inequality, you want to take the log and use the same base as the exponent of both sides and solve. If you have a logarithmic inequality to start with, exponentiate both sides using the appropriate base, meaning the same base as what the log is. You must check for domain restrictions, but you only have to do this on logs. You're only going to have to check for domain restrictions on logarithms. And that's because, guys, if we start with an exponential function, what's the domain for an exponential function? What are the values of x we're allowed to use? All real numbers. Here's what an exponential function looks like. Our domain is all real numbers. But if I have a log function with that same base, that log function looks like this. It has a vertical asymptote, and it looks like that. What's the domain of this function? X has to be greater than 0. So I can never have answers for x in a log function that are negative. They always have to be greater than 0. And that's something I'm going to have to keep in mind. These formulas are important. I just showed you those in the warm-up. Let's take a look at number 12 here. Solve the inequality and then check on the graphing calculator. All right, so looking at this first problem, this is a log. We said if we have a log with an inequality, we're going to, that's a log with an inequality, we're going to exponentiate both sides using the appropriate base. What's the base here? 10. So I'm going to do 10 raised to the log x on the left is less than or equal to 10 raised to the 1/2. What's another name for 10 to the log x? What's the base here on this log? So what's the answer going to be if there's really a 10 there? Just x. So this answer then is x is less than or equal to, and how could I also rewrite 10 to the 1/2? Square root of 10, right? So we're saying that's our answer. But when I look back, I started with a log function. What is the restriction on a log function? What did we say the restriction is going to have to be here? Right, x must be greater than 0 from the very beginning. So I have to add that on to this, okay? I don't want to write two inequalities. I'm just going to say x has to be greater than 0. And that's going to be our solution to that inequality. I want you to take a look at this. Let's actually use Desmos. So I'm going to graph log x. There's what it looks like. And I'm going to graph y equals 1/2. So we're looking at what are the x's that make this red less than the blue? Because look back at our original problem, guys. Our original problem was We wanted the log function to be less than y equals 1/2, less than or equal to. So when we look at that, see how all these red values here up until that point, and what do you think that point probably is right there? Should be square root of 10, okay? And so these are our solutions from x being greater than 0 until I get to that point. And if you're kind of a visual learner, that might help you to see it better, why it has to be greater than 0 and less than the 3.162, which is radical 10. All right, let's go back now to our notes. Looking at number 13, what kind of function are we starting with, a log or an exponential? Exponential. Do I have domain restrictions on an exponential? Nope. So we're going to just solve this. I have to isolate the exponential part. So I'm going to go ahead and subtract 1, divide by 2. And now I have this down to just the base with the exponent. Bless you. What's the inverse operation for an exponential? Log. And I have to use the same base as what I have here. So what's the base here? E. So I have to take log base E of both sides. What's a shortcut of taking log base E of both sides? Natural log. So I can do natural log of e to the x has to be less than natural log of 3. What does this simplify to right here? Just x. X has to be less than the natural log of 3. That's going to be our solution. Questions on that? Yes.
So the x just is like from the coefficient, right?
Right,
And then the natural log.
right. Here are some things we also need to know. Log 10. What's the answer to log 10? 1. Natural log of e. What's the answer to that? Those are some things we need to recognize when we see them. Okay, and then one more. What's log base a of a? That's also 1, right? When the base is the same as that, a to the what is a? 1. All right, guys, I want you to try one with your group now. Let's do this. So what if I gave you negative log x is greater than, actually, let's do log base 3 of x. Negative log base 3 of x is greater than negative 2. So negative log base 3 of x greater than negative 2. Right. Some people I'm hearing pencils drop. I think they're getting close. What do we do first here? I want to get the log by itself, so I need to get rid of the negative by doing what? Divide by -1 on both sides first. Does anybody remember what happens when we divide an inequality by a negative? Yeah, Jackson. Yep, we have to flip the inequality. So now we're going to have log base 3 of x has to be less than 2. How do we undo log base 3? What's the opposite or inverse operation? No. Yeah, you got it. So I have to exponentiate both sides with the same base as the log. So I do 3 to the log base 3 of x is less than, what do I do over here?
Equalities.
No.
Oh, wait, no, 6.
I'm doing 3 to the log base 3 of x. So if I exponentiate this side with a base of 3, I exponentiate this side with a base of 3. So it's going to become 3 to the second.
Oh,
We do the same thing. It's basically just making these into exponents. That's what exponentiating is, with the same base. Has to be the same base to work. So what is 3 to the log base 3 of x the same as? Just x. Has to be less than 9. And then we have to check to see, do we have a restriction in our domain back at the beginning? We have a logarithm. So therefore, what do we know about x? X is going to have to be what? Greater than 0. So we just need to add this on like that. Did any of you figure that out? Okay, good. Pretty tough problem. So again, just to review, if we start with a log, we have to be looking for restrictions on the domain. We have to exponentiate with the same base as whatever that log has. If we start with an exponential, we have to take the log of both sides and use the same base as what we started with. All right, guys, we're going to come down here and we're going to do just a couple of problems from this section. Before we try this problem, though, off to the side, I just want you to think about this. Go back up here. What if I asked you what is the answer to 5 to the x times 5 to the 2x? Can anybody simplify that? Jackson? You got it. When we multiply with like bases, the base stays the same and we add the exponents. That's how we multiply exponentials. Let's look down here now. Now we're trying to factor, okay? Trying to factor this. I have to look here first. What values multiplied together will give me 3 to the 2x? Look back here. 5 to the x times 5 to the 2x was 5 to the 3x.
oh, yeah.
Right, good job. So it's 3 to the x times 3 to the x. Now I'm going to look here. What factors of 15 will subtract to give me 2? Factors of 15 that subtract to be 2. 5 and 3. When we check the outers, 3 times 3 to the x is what we get. When we check the inners, 5 times 3 to the x is what we get. We're trying to get a negative 2 times 3 to the x. Do you know how the signs need to go to make that happen? Yeah, we need a minus 5 and a plus 3. All right, we're going to work this one together. So we have two factors, and they have to equal 0. So 3 to the x minus 5 could be 0, or 3 to the x plus 3 could equal 0. 3 to the x could equal 5. 3 to the x could equal negative 3. Can you solve that now?
No.
Anybody think they know the answer, the exact answer? It's okay. What do you think it is?
Log base.
That is an exact answer.
Oh,
Yeah. Okay. And that's your only answer?
no, I got log base.
Oh, okay. Do you guys agree with him that there should be two answers? No, so we're getting some no's. Let me show you something here. I graphed this. Here's the first function, and then we want to know when it equals 0. When I graphed it, there's only one solution. So why is there only one?
Okay.
Okay. Here's what the one answer should be. 1.46 approximately. So you said it should be x equals log base 3 of 5.
Yeah.
Okay. I bet you're right on that. Let's see. 1.46 is that approximate answer. Let's see what math log base 3 of 5. Oh, cool. Yeah, that's exactly what we got when we found that point of intersection. So that's right. But what's the problem over here? Can anybody explain why this ends up being no solution? Not for this part? Well, it's not a log, it's an exponential. What if x is -1? What's 3 to the -1? What if x is -2? What's 3 to the -2? Do exponential functions, no matter what this x is it ever going to equal a negative? No. That's the reason this does not even have a solution. That's the only solution we get, is right there. Okay? All right, guys, we're going to do one more, and this is number 5. All right. Up to now, we have had easy exponentials. We've always had them as a to the b equals c. When we have a to the b equals c, and we can easily rewrite it in log form and go and be done with it. But I can't do this here. I have a to the b equals a to the b, and I can't get like bases. I can't do much of anything. So here's what you need to do on problems like this. Take log base 10 of both sides. You can take the log with any base of both sides, but on these kind of problems where you have different bases and you have exponents, here's the way you want to start it. You have log 2 to the x minus 1 equals log 5 to the x plus 3, negative x plus 3. All right, guys, what do exponents become? Exponents become what? Coefficients. So we are going to have to make these coefficients. So now we have x minus 1, and that's in parentheses, log 2 equals negative x plus 3 log 5. We're trying to solve for x. We got to get x to get x's all together and solve for it. What am I going to do with this? What do I have to do with it? What's that called? Distribute. So I'm going to have x log 2 minus log 2 equals negative x log 5 plus 3 log 5. All right, guys, what do we have to do if we just have a normal problem like 3x plus 2 equals x plus 1? What do? Get the x's together, right? So that's the same thing we have to do here. We have to get the x's on the same side and the constants on the same side. So these are going to have to go on the same side. So what am I going to do with this? Add it over there. So I have to add x log 5. What am I going to have to do with this? Add it over to the other side. So add log 2. None of these are like terms. So what I have is x log 2 plus x log 5 equals 3 log 5 plus log 2. Anybody know what to do with this now? I'm trying to get x by itself. I have an x in this and I have an x in that. X here. What can I do with it to get it as one x and not two x's? I can't combine them. They're not like terms.
Sure.
No. Factor out an x. Can I factor out an x there? What am I left with if I factor out an x? Is that what you were saying, Matt?
I was saying like
GCF? Yeah, you're right. Yeah, just factor out the x. So what are we left with if we factor out the x? Log 2 plus log 5, right? What can I do with, let's simplify over here a little bit. What can I do with this 3 that's a coefficient? Make it a what? Exponent. Okay, let's do that. Let's make it an exponent. So now I have log of 125 plus log 2. Does anybody remember what you can do if you have logs with the same base and they're getting added? What it can change into? Multiplication. See if you can finish this. The answer is actually a pretty easy answer. See if you can do it.
I like it. And it's oh, it does turn into a log base. Cool. You just have log, you have a log. No, don't have to multiply this. You have log. We have also work. And I will have to. It wouldn't.
You could give me this answer right here, and it's correct, but it's not great. It's not the easiest way to write it. Does anybody have an easier way of writing this answer? Addition of 2 logs can turn into multiplication. Anybody get a better answer? There's a really nice answer for this. What'd you guys get?
You were thinking that.
Oh, it's close. What'd you get? It is. Good job. She's right. It's log 250. Did anybody else get log 250? Okay, good.
I'm just trying.
This is going to turn into multiplication, log of 250. This is log of 10. What is log of 10? Just 1. So therefore, the best name for this is just log 250.
Oh.
Okay?
Oh, that's it. I was trying to find like the approximate.
And you could have had this in your calculator.
That's what I got.
I want to show you something here, guys, how you can check this. Okay, look, I just put in my original problem. I'm going to zoom 6 it. I'm going to find out where those intersect. If this is on the calculator part, shoot, I wouldn't even bother with all that stuff we just did. But if it's not on the calculator part, we have to, or if it asks for the exact answer. But look, I'm going to find that point of intersection. Boom, boom, boom. 2.39794. Well, what's the log of 250? Log of 250 is 2.3794, right? Same answer. Okay. All right, guys, we're going to stop right there. Make sure that you do the homework. That's the stuff.
Go behind.